A traditional view on a software language is that the language is defined by its syntax and its semantics. This definition, however, leaves out one important aspect, if not the most important one, that of language tooling, by which I mean an integrated development environment. Language workbenches, on the contrary, consider tool support first class. Given a language specification, a language workbench outputs a tailored, high-quality IDE for it. Obviously, different language workbenches support different features. However, there are many things in common in terms of the features that the languages, which are defined with the language workbench, have. For example, languages can use textual, graphical, or tabular notation. Their semantics can be either translational or interpretive. The code editor may or may not support syntactic services such as syntax highlighting, code folding, or auto-formatting. This feature model is due to Erdweg and co-authors. As they mention, with few exceptions, all features apply to the languages that can be defined with the language workbench, but not to the language definition mechanism of the language workbench itself. This is the focus of my today's presentation. The idea is to consider the language definition mechanism of language workbenches and do so from an algebraic perspective. The languages, concepts, aspects idiom is central in the conceptual framework that I'm going to present now. A language is a set of concepts or constructs such as if statement, while loop, and so on. Each concept is a tuple of aspects, each of which represents a certain concern in the language specification. Examples of aspects include structure that defines the abstract syntax of a concept, view that defines its concrete syntax, highlighter that defines syntax highlighting. I present now 5 groups of possible features that a language workbench can have. The first group is about the behavior of a language workbench itself. A language workbench can be bootstrapped. A generalized notion is meta-language workbench. Those can be used to develop other language workbenches. Customizable workbenches allow specifying and modifying their behavior and appearance, for example, the menu commands, by means of designated meta-languages. Standalone workbenches allow hiding their meta-functionality. Restricted workbenches are tailored at developing or evolving a particular language. The meta-definitions group is about how languages and meta-languages can be defined in a language workbench and what the expected expressive power of the meta-languages is. A language workbench should provide mechanisms to define dependencies and relationships between languages, concepts, aspects. For languages, this means, for example, the ability to define and adequately support language composition. For concepts, it is the ability to define inheritance between language concepts. Meta-languages should support parameterization in definitions, with the goal of fostering reuse in language specifications. Languages can be defined using an object-oriented style or algebraic style definitions. Object-oriented style means mechanisms, for example, to define interfaces of languages, aspects, concepts, prototype-based definitions, and so on. Algebraic style definitions are about defining signatures of languages, aspects, concepts. It should be possible to follow the a la carte approach when defining constituents of languages, aspects, concepts. One could expect support for modular definition requires and provides interfaces, mechanisms to specify isomorphisms or equivalence relations on languages, aspects, concepts, and so on. Now let's talk about in what ways the meta-definitions can be modified. First, a language workbench can support defining custom operations on languages, aspects, concepts. An example is extracting an aspect from a concept and then applying it to another concept. For example, I drop in the highlighter definition from concept if statement to concept while statement. Extending on this, a workbench can provide mechanisms to express morphisms. For example, a homomorphism can be defined on aspect view to support having keywords in multiple natural languages. The theoretical framework for a comprehensive support of transforming meta-definitions are signature morphisms and their extensions in the context of the theory of institutions. These would enable customizing workbench behavior in arbitrary ways, not necessarily semantic preserving. The meta-process group is about the functionality to support a language engineer during the language definition process. A workbench can provide a mechanism to introspect itself. It can also support querying meta-definitions. A workbench can have mechanisms to import and export meta-definitions and meta-artifacts, such as documentation, metrics reports, and so on. A workbench can also have mechanisms to specify the very process of language specification. For example, which concepts and aspects need to be defined and in what order. Finally, the mogram level group is about functionality that the language workbench can have with respect to mograms. This includes generating sample mograms, performing operations on them, for example, slicing, mutation, or defining a feedback loop from mograms to change the language definition or even the behavior of the workbench itself. Fundamentally, the proposed vision is based on a simple idea of having algebraic specifications for all stages of the development journey in a language workbench. This will hopefully help us in developing the next 700 language workbenches. Thank you.